Hey Spring fans! Today we're going to talk about some of the new functional reactive endpoints inside of Spring 5. Now Spring 5 is not here yet. It'll be out first half of next year. But they're doing great early release candidates that you can check out right now. You can kick the bits. The really big feature, sort of the killer feature I think in Spring 5 is the new reactive programming support. And up until now, that support has been basically a reimagining of the underpinnings of Spring Framework and Spring MVC itself to support a fully reactive pipeline. So basically, we've retrofitted some of the existing Spring MVC component model and put it on top of a net new Netty-based engine. Now, you can use some of these reactive features in a sort of degraded mode on top of a Servlet 3.1 based container, but the real power comes when you drop into this Netty-based engine, this runtime that we've developed to support reactive workloads. Now, the benefit of porting over the existing Spring MVC components is that you can take your existing applications and move them over piecemeal, and that's all very well and good. And that's I'm sure going to be an interesting topic for another discussion another day. But today I want to talk about something that Spring Reactive Ninja Arjen Poetsma just dropped a few days ago. He talked about the new functional reactive endpoints. So if you saw this blog, I encourage you, if you haven't seen this blog, I encourage you to read it. If you have seen it, then read it again, because it's really, really, really key to what we're about to do here today. New in Spring 5, Functional Web Framework. This is a different component model, and for some people, this is going to be exactly what they wanted for a long time. Right? This is going to be very familiar to people who have worked, for example, with Scalatra or Sinatra, or even Spark Java or other technologies like this. I think it's a natural addition to Spring MVC. It's a very natural addition to what we're trying to do with Spring MVC, which is to be more powerful, to provide a better experience, and to support mix and match component models wherever appropriate. So today we're going to go a little bit beyond what Arjen did in his introductory blog post. We're going to go ahead and build a simple Spring Boot application. Now, as work is being done in an ongoing way on top of Spring 5, there's also work being done in the Spring Boot team to integrate some of the new bits into the auto configurations for Spring Boot. So the experience is meant to be similar to what you get right now. If you're using Tomcat or Jetty or Undertow, for example, in an embedded mode, you should just be able to check a box and start up a Spring Boot application and have full access to the reactive runtime. But as the functional endpoints that we're about to discuss are pretty new, we'll forego some of that auto configuration, but we'll start with that auto configuration as the basis for our project and use that as a way to pull in the right library. So we're going to go to start.spring.io, of course, and we're going to build a beautiful reactive application. We use Spring's reactive web support. That's experimental. You can see it's marked experimental here. We'll use MongoDB, Spring Data, not MongoDB. We'll use I think that'll do. That actually ought to be enough for us to get started. So let's go ahead and hit generate, and we'll get a new zip file. And we're just going to open up the zip file, and we'll get a new project, and we can import it into our IDE. Now, the Spring Reactive support, the auto configuration, is useful because it brings in a few libraries that we need, and it gives us an idea of what is required to get this stuff up and working. But we don't need all of these bits. So actually, we're going to take apart, we're going to dismantle it, remove it, and we'll keep only the bits that we need for this particular example, kind of working outside of the sort of the rails right now. Okay, so we're going to use Spring Web Reactive. This is a Spring Framework library here, and we'll bring in the Netty buffer. Netty is the I/O library that underpins a lot of reactive technologies and implementations, ours included. We bring in the Reactor Netty library. Now this is the project reactor, right? io.projectreactor.ipc module that supports our integration with Netty for evented based I/O. And we'll also bring in um, the JSON data binding module, right? So JSON data bind. You must be able to spell it for this to work. Okay, there we are. And that I think will do. Now again, when this is final, when it's GA, and when you've got the actual bits, you won't need to do nearly so much. In fact, I expect that a lot of this will go away in the very next release, right? This functional reactive stuff is very new, so it hasn't been automatically integrated for us. But by choosing the Spring Reactive support, we get the milestones, and we get this special dependencies build. One thing that you should be aware of is if you accidentally neglect, as I have, to specify Spring Boot 2.0, then you're going to get a bad experience. So make sure you push this up to 2.0.0 build-snapshot. Okay. Now, what we're going to do is we're going to build a simple application that uses MongoDB. We're going to do it as we would any kind of application. We're going to build an entity. I'll build an entity here, borrowing from Aryan's example in the blog, an entity of type person. So I'll use the Spring Data document annotation here, and we'll create a string for an ID. Right, that's a very natural document ID, unlike JPA rather, where you might use an ID like long. MongoDB prefers strings for auto-incrementing unique values, and we're going to give it a name value, a field, and we'll give it an age. We'll give the person an age, okay? And a constructor, and another constructor, although I'm not even sure if we need that, and some getters, naturally, and a toString for ease of debugging. Very good. So now we have that, and we want to be able to read and work with entities of this type. So I'll create a repository. I'll say extends Mongo repository, and I'm going to manage entities of type person whose primary key is of type string. There we are. And I'm going to want to iterate through potentially unlimited amounts of data, large amounts of data. So I'm going to take advantage of a feature that's already in Spring Data since last year, a feature that lets me define finder methods using deferred or stream-based types. So I can say, for example, that I want to get a stream of person, and I want to find all of them, right? So I'll just say all. I'll provide a custom query like this using the MongoDB bson query syntax for everything, basically. And I want to get a specific finder. I want a specific person, so I'll say, give me a completable future, right? Both of these cases map naturally to the world of reactive programming. So we'll exploit those here for our own benefit, okay? Now, we want to create some records, as always. So I'm going to create some sample data. I'll say class sample data CLR implement command line runner, and we'll override the command line runner interface, providing a callback here, and we'll inject our person repository so that we have it to work with. Now, in Spring 4.3 and beyond, we don't need this auto-wired annotation. So I'm trying to remember to leave it off, but I realize that a lot of us are still accustomed to having to add it. So maybe I should just leave it. I don't know. We'll see how that goes as I do more of these. So stream.of, and we'll create some records. So my name is Josh, naturally. Nice to meet you. Good to meet you. I'm joined, of course, by my heroes and friends, Stefan Maldini, the project lead of Reactor, which of course underpins the WebSocket support in Spring 4 and underpins the reactive web runtime in Spring 5. So a very, very pivotal guy. And then, of course, Aryan Putsma, whose amazing blog post set me off on this course. Rosen Stoyanchev, another Spring Web ninja. There we go. That's a small. Maybe we should add a few more. Why not, right? The one thing that's worth underscoring is that we could very well handle millions of records with the approach that we're about to investigate. So my simple sample data is just sample data. Okay. So for each name, we're going to save a record in the database here. We're going to say person repository at save new person, and we'll pass in the name, and we'll pass in an ID. I don't want to pass in the name in the constructor here, IntelliJ. Thank you. rather the ID. I don't want to pass that in. So we'll say name, and I'll use a new random to get a random int. There we are, and there we go. So there's my sample records, and that is, I think, enough, right? We now have the everything we need to work with MongoDB and to see that reflected on the console if we want to. So I can say find all for each system.out.println. So I'm going to basically use a method reference here, a Java 8 method reference, to iterate through the results. And this is, by the way, I think a key distinction for these component models. A lot of what we're doing here in the reactive stuff, in the Java DSL, the Java configuration DSL for Spring integration, the Spring security stuff, a lot of the really cool things that we're able to do in Spring these days are because Spring, rather Java 8 is so ubiquitous. It's so popular, it's so ubiquitous, and it's such an obviously good idea, right? There's so many good features in there, including lambdas, so that it lets us build a lot of DSLs that would otherwise be their own exclusive purview of other languages. So I'm very happy to see this approach becoming more prominent. So there we go. There's our records in the database. Now let's stand up a simple REST API. And we're gonna do that using a custom server. We have to stand up a server here. And again, this is not something you're gonna have to expect to do too often, right? You're not gonna do that too often, but we need to do it this time. So we'll create a server, and our server will need an HTTP handler, and we can create a handler by passing in a router function. And this is what we need to define, but for now, let's assume that that's been defined here pretty quickly, that it will be defined, and we'll just carry on defining this HTTP server. So we're going to define a handler that will take its sort of directives from this router that we're going to build, this router function, which is the root, if you will, of our functional Spring MVC endpoints. Okay, and then we're going to create an HTTP server here, an HTTP server, passing in a custom port, right, 8080, or there we go. And naturally, this is the kind of stuff you would put in a property file, or you might even just inject server properties, right? The Spring Boot server properties here, and you could say server.properties.getPort, right? That would actually give us something. So if we look at the default server properties here, we can see that the default port is as yet unspecified. Is that true? So maybe we shouldn't lean upon this. If the value is unspecified in Spring Boot, then Spring uses the socket utils to find an otherwise unused port and so on. But for our purposes, that's a little much. Let's just keep it simple so we can understand what's happening here. Okay, so 8080. There you go, good. And now we need to start the server by using a new reactive HTTP handler adapter. We're going to adapt our custom handler here, and we're going to return the server, the HTTP server, and there we go. That's the simple machinery. And again, there's a lot of other things we could do here, but we've created as an HTTP engine. This is the Reactor HTTP server component. This is from Project Reactor itself. And then the runtime, the sort of the component model that the reactive Spring component model is being provided here by this reactive HTTP handler adapter and the HTTP handler here, right? Now let's talk about the router functions. That's the real meat of this particular sandwich. That's the stuff that we care about here, right? So we're going to define a router. Router function, and to do so, we need to return a route, like so. And we're going to do the long-form version of this using the fully qualified static methods and classes, but then we'll see that this DSL becomes much cleaner once you strip away the sort of static method references by using static imports. Okay, so we're going to use get persons. Okay, this is actually request predicates. So there's that. That's the long form version of that. And then what it's expected is a lambda to handle the request that arrives at persons, any request, right? We can be more specific, of course, and we can specify lots of different routes. So here we can say, and request predicates dot route dot get rather person's ID, and then we specify a lambda to handle that request as well. Okay, so right now I'm passing in just default lambdas here, which will not work naturally. This won't work, but we can fix that once we've got the sort of scaffolding done. I find it helps to flesh out what we want to do here first, and then provide the actual definitions for those lambdas, or those objects. And we'll do that actually in another class. That's another reason that it's not particularly valuable to implement that code right here, because it becomes kind of an eyesore, right? So there we go. This is our simple, mapping, if you will. This is a lot of what we're doing here is what would have done in sort of a handler mapping in Spring MVC. Now I can do a lot more, of course. I can, for example, use I can further predicate my requests. I can further constrict the qualifying requests, and I can say, for example, request predicates dot accepts media type application JSON. Right. So I'm only gonna, in this case, I'm only gonna respond to incoming clients that will accept the application JSON type for media. Okay. It becomes a little redundant in our case to do that, so we'll just leave it off. But suffice it to say, there's a lot of power there. Now, let's talk about those lambdas. Let's talk about these implementations. Aryan had a good idea in the blog. He factored out a lot of this code into a separate class, and then he just reused that as he was developing the example. And I think that's a good idea because it makes it easier to test. It's more approachable, and it removes a lot of the business logic away from the routing definitions, right? So we're going to do the same thing here, knowing that we're going to have to provide two methods for these different endpoints. We'll create a custom class here called a person handler. Okay, so we'll say class person handler, and we have to respond with a response. That's the Spring reactive payload, if you will, the envelope payload for the response that we're going to send back. And this is going to be a method that will handle all the records, right? And then we're going to have another one that will respond with just the by ID record. So with that in mind, the all method is going to return every instance of a person. In the reactive world, what we're trying to do is we're not trying to return a collection. Remember, we're trying to return an object that represents a potentially endless stream of values. So a collection isn't a great fit. We're trying to return a potentially endless stream of values that will give us a notification when new values are available, right? So in the Reactive Streams API, the Reactive Streams API is a sort of agreed upon language for describing reactive back pressure. It's something to which Pivotal and other stakeholders like Lightbend, who are the progenitors of Akka, and Red Hat with their Vertex, and Netflix with RX Java 1.0, which of course doesn't have Reactive Streams implementation support, but will in Reactive Streams, RX Java rather 2.0. All of these signatories sort of define the language of reactive streams and back pressure, and they did so good a job that base definition is now part of the JDK 9 effort. So JDK 9, Java 9 will have the Java util concurrent flow package based on the sort of work done in this description, this document. Okay, so in that world we have this idea of a publisher, and a publisher can publish. It's a potentially unbounded stream of values that can publish either 0 or a bazillion, right? Infinite number of values. There are specializations of those for convenience inside of the Reactor project, right? Our Reactor project, Reactor 3.0 in specific. And so if we're going to return a stream of one or more values, that's called a flux. Okay, so flux of person. And of course, to handle serving a response, we need to interrogate and work with the request. So we'll pass that in here. Okay. Make that a null for now. And then same thing here, except instead of returning a flux, we're going to return just one object, one value, 1 or 0 values basically. It's either there or it's not, but it's not going to be more than one value. And in the Reactor world, this is called a mono. Both are subclasses of publisher. Okay, so we get all of the understanding that we have by using the Reactive Streams API. We get all that. We benefit from all that, but we're able to do more interesting things now that we know we have a certain bound. We understand the constraints of the data that we may have. Okay, so for the all method and for the by ID method, we've stubbed it out as we were trying to do. Now we can reuse that handler. We can tell Spring to put that, to inject that object, to make it available as a parameter here. So we'll say handler all, okay, and then we'll say handler by ID. Now we're using method references here, and I think that's very, very clean, right? We're not worrying about the business logic. We just know that this lambda is going to be invoked, and we can much more readily test this. I think that's a nice compromise between sort of the Spring MVC, the classic Spring MVC component model, and the stuff we're doing here. Now, the all use case is pretty darn simple, isn't it? Right? We just need to take the data coming from our person repository and send it back as a request. And I'll provide an explicit constructor there. So we say person repository dot all, and we got a stream. So what I want to do is I want to take this, I want to take that stream and adapt it into a flux, right? So I'll say, give me a flux, and then I need to wrap the resulting value there. The resulting value, I want to wrap that in a response and then send that back. So we can say now response.ok, and naturally there are other builder methods here, okay, bad request, not found, etc. This is very similar to the Spring MVC response entity. So it's very natural to move back and forth between one program model and the other. So we'll say response.ok dot, and then we need to create a body. Now remember, this is an engine that's optimized for dealing with potentially unlimited amounts of data. So our notion of a response body, the content length, a lot of these things that we have taken for granted in traditional HTTP, these things have to be rethought a little bit. In particular, what does it mean to stream JSON, right? With JSON, we don't really know if we're at a sort of a chunk of data naturally. So there's extra work that has to be done underneath in the engine, in the rendering for this JSON. And we've done that, of course, but for now, a lot of that stuff surfaces in terms of this this body inserter interface, right? So we're going to use that here. We're going to say body inserters dots, and we're going to create an inserter based on a publisher. So we're going to write data to the body. We're going to insert data into the body by consuming data coming off of that flux. Okay, so flux. There we are, and that should do. Cannot resolve method. Oh, the other thing we need to do is, like I say, we need to give it a frame, right? We need to. This is very similar to TCP or classic TCP and classic network programming. We have a message frame now, right? Because we're streaming a potentially unlimited amount of data, we need to help the framework itself frame the data, and it needs to do that in terms of how, what it means to be one person in a collection of people, basically an unlimited stream of people. So that's the boundary. That's why we have to provide this, not because of generics, but because of that. Now, this other method, this is a little bit more interesting because we don't know, we hope, right? We expect that we're going to have an ID, a parameter here, a path variable that's passed in as an ID. So let's write that code with the assumption that that may not be there. So we'll say request.pathVariable ID, and if it's there, what we get back is a Java 8 optional, right? So ID optional. We can say optional map ID, and then we can say that we want to get the data from the repository. So we'll get the find it by ID, passing in this ID here. And if we find it, then we want to map that into a mono. So we're going to say people or person mono dot from future, because we're gonna get a completable future here, right? Where's our interface here? A completable future. Passing this in, and then if we don't, then if we have that, we want to then create a response to hold it, right? Just as we did before. So we'll say the mono will be wrapped using response.ok.body, and here we're going to use the body inserters again from publisher mono, and again we need to do the demarcation there, the framing, if you will, and then with that we should be able to do. We have one more thing to do. We need to handle the situation where it's not there. So that's the or else throw sort of clause. We're going to say if we cannot find it, if we cannot load the data, we should throw a proper custom exception. But let's just argue that we don't have the right state. Oops, there we go. So I encourage you to do an infinitely better job than I have here. Now, we can see that the IDE is offering to help us here. It wants to help us really, really badly. Look at the uses of things that could otherwise be method references, and look at all these static imports. So we'll come back to that in a second, but let's confirm that everything's working, shall we? Let's go ahead and start it up. And localhost 8080, and what did we say? We called it the persons endpoint. So persons, whoops, it's not one because that ID doesn't exist. It's these names here. Did I delete that one? There we are. So there's the records, right? I can look up the data as much as I want, and I get the results as I expect. So let's go back to our data now. Let's go back to our code and just clean it up a little. I think we're in a good place, and I think you can already see how it's very natural to work with the Spring Data support and mix and match that with the reactive APIs. Now, a few things to say about that reactive support in the Spring Data modules. First of all, that's limited to just a subset of the modules that support reactive APIs. So in Spring Data itself, you can use it with Couchbase, with MongoDB, with JPA, but this sort of depends on the underlying implementation, and you're not going to always have reactive semantics. Maybe you'll have streaming semantics, which is still better than a select all sort of approach, but it's not exactly the same thing. There's some interesting news that just came out of Java 1 last week. Oracle has announced that they're working on a sort of not an extension to JDBC, but another project, a parallel effort to introduce reactive programming support for database drivers. Right? I'm not sure if that's JDBC itself or if it's a side branch or something like that. But the point is that evidently they're at least thinking about this as well. So this could bode very well for those of us who are trying to work with reactive SQL databases. Okay, now we are going to remove this. So we'll say add on-demand static import for the router functions. Okay, that helps considerably. Add on-demand for request predicates. Great, that helps considerably. And I think you agree, that's not actually that bad at this point, right? That becomes a very clean one-liner. So there's that. And down here, we can use method references here. Okay, and there we go. Not bad. And I can even use this. I can use on-demand statics for the predicates here as well. Okay, that I think, my friends, is a quick look at the reactive functional endpoints in Spring MVC 5. I hope you'll go to start.spring.io and get the bits and kick the tires, if you will. check out Aryan's amazing blog, and stay tuned for more of these videos. Thanks very much.